Hello all. Let's get started with advantages of MBD. So there are various advantages of MBD. We will go one by one and we will see one by one every advantage. Okay. So several project teams can share a common design environment. Designs can be directly linked to the requirements. It is possible to integrate testing with design to detect and rectify the failure continuously. Algorithms are refined through multi-domain simulations, automatic code generation, embedded software code, automatic generation of documentation of the code. Test suite can be developed and reused. Hardware agnostic system design reused. Okay, so now let's start with MBD workflow. So as you can see in this diagram, research, requirement, design, implementation, integration, and test and verification. These are the important parameters in every development process. So research and requirement parallelly working like implementing in a design implementation where we are doing a modeling, and what we are designing that going to be implementation that converting into code and all these things, and integration after that is happening. This process is happening continuously, and each and every phase is connected with testing and validation. So there is like simple way we can add any changes if we want, we can do easily in this process, okay, in this workflow. So let's know more about this workflow. Different project teams use the same design environment for all phases: requirement, analysis, design, implementation, and test in model-based design workflow. Models are enhanced and reused at every level, so the development time is reduced and the interpretation error are eliminated. Development time is reduced and interpretation errors are eliminated based on the research and requirement system engineering defined low-level requirement as executable specification using models. Different physical behavior are simulated using behavioral models, and then they are used to make decision and design trades-off, which makes the process more straightforward compared to the traditional approach. The models are used clarify requirement and specifications. Software developers further enhance these models in details. They can simulate these models to rectify any behavior or interface related errors. After a few iterations of refining the models, the design is finally verified. From the model, production engineers automatically generate the production level HDL code. The system level test cases are reused to test the generated code. The behavior is then also verified on the target hardware by reusing the test cases. Requirements can be imported into model and linked to the design, thus establishing requirement to design traceability. In this way, the model-based design offers an excellent choice of a complex system that provides a shared development environment and reduces the development cost, time, effect with simulation and auto code generation. Reuse of the model design and test cases lower the number of defects identified during the latter development stages and stimulates the manual effects. Okay, so this is all about the workflow of model based development.